This tutorial is to show how to run a dependent samples t-test. This is the data. So we're going to look at whether instruction has an effect on students' pre and post-test scores. And we collected the test scores from 10 students, and we have the pre and post scores. And we can get the means and standard deviation from their pre and post-test scores. And so we can also get a based on the pre and post-test score, we can also get the again scores. So basically, that's the difference between the pre and post scores. So I'm going to use the post score minus the pre-test score. And so we can get the difference from each person. And we can also get the means and standard deviations for the again scores. So we do see that there's a difference between pre and post test scores. We want to see that if the difference we see here is just a random sampling error, or there's a real difference in terms of the population data. So we're going to run a test, and we're going to go through the hypothesis testing steps. And so we'll have the stated the null hypothesis and alternative hypothesis. And this hypothesis will be about the population value. So our null for this example is the pre and the post means are the same in the population. And the alternative is the pre and post means are not the same in the population. So this is a non-directional hypothesis. If we draw a graph, so for the null and alternative hypothesis, this will look like this. So the null, basically, it will say the two means are the same. Alternatives, the means, the two distributions, pre and post-test distribution, the means are different. And significance level is 0.05. So if there's only 5% chance or lower that the difference we see in our sample data is due to a random sampling error, we're going to reject the null. The test is the dependent t-test because the pre and post scores are related. And then we're going to find the critical region. To find the critical region, we're going to find the t-critical value. So to find the t-critical value, we need a degree freedom, since we only have one group. And so we actually have one population value to estimate. So just look at different scores. So that's n-1, which is 9. And so we can use the t-table to help us find the critical value. So we're looking at a two-tailed test. The alpha level, significance level is 0.05. Degree freedom is 9. So the critical value is 2.262. That means beyond these t values, there's a 5% chance of find the difference is larger. And so in the graph, we can see that these are beyond this 2.262, it's 2.5% each side. So we're going to calculate the test statistic from our data, and that's the t observed value. And we're going to compare the observed value with the t critical value, which I'm going to enter here. So it's plus and minus 2.262. So this is the t critical value. And then, so we're going to compare the observed value with critical value. So if this falls into the shaded region, that means the difference we see is kind of huge because that's less likely to occur. So we are willing to reject the null. To calculate the observed value, we're going to use this formula. So the t formula has the difference, the mean difference in the numerator, and standard error in the denominator. So we again will compare the sample mean difference against the sampling error to see the difference is how large is it larger than standard error. And so we are going to compare calculate the mean difference first. So the mean difference from sample is basic. It's actually just 3.1 here. So I can just write 3.1. Maybe let's just copy over here. And then next we're going to find the standard error. To find the standard error, we're going to find the standard deviation for the sample mean difference. So standard deviation is here as we calculate standard deviation for our sample mean difference. And then so I'm going to use decimals. And next we're going to divide the standard deviation by next we're going to do a square root of the sample size, which is 10. And then we're going to find the standard error of the mean difference. And so the standard error is just to do a ratio of this. So this is the standard deviation divided by standard root, square root of the sample size. So I get 0.99, 0.99, which is the standard error, which is kind of like, it's approximately 1 standard error. So next is we're going to compare the mean difference with the standard error to calculate the observed t. So it's mean difference divided by standard error. So we'll get this is the observed t value, 3.12. Yeah, so the mean difference is 3.1, and because the standard error is 1. Yeah, so we can see that the mean difference in terms of standard error units is 3.1, which is falls into is larger than 2.26, and so falls into the shaded area. Yeah. So let's see here. I think this does not okay. So I need to move this down 1, and this is going to move over here. Yeah. So this is the observed t value. And next we compare the observed t with critical t, because observed t is larger than the threshold. So we're going to reject. So this is we compare critical value and observed value to find the statistical significance. Next, we're going to use the p-value approach to determine significance. So this is again we go through the hypothesis steps. So first 4 steps are the same. The only thing that with the p-value approach, we don't need to calculate the t critical value. So we just need the observed value, which is 3.12. And then next we need to find what is the probability of finding 3.12 in the t distribution. We could use the t table to help us estimate. So degree freedom is 9, and we know that beyond 2.262, there's a 5% chance of finding t-value this large. So we can just go across to find a value that's closer to what we calculated, which is 3.12. So we can see that it's closer to 3.25. And this is the probability of finding of value 3.12 is closer to that is 1%. So that's our estimate. And we can calculate the exact p-value using formula. So t distribution and t distribute. And then we put the 3.12, that is the t value, the x here. Degree freedom is 9, two-tailed. And we can see that the probability of finding a t-value this large is 1.2 percent chance. So the probability is low if there's no difference between the two means in the population. So the chance of finding a sample mean difference this large is rare. It's just a 1.2% chance. So it is less than our criterion, which is 5%. So we are willing to reject. So both approach will get the same results. So we reject null, and we all conclude that the alternative is true. And so we'll say that the mean difference, there is a difference in the population means. So this is the end of the tutorial. Thank you for watching it.